You might be turning into a crab.
What? What?
Maybe not you right now, but it's a real thing happening in nature. It's one of the weirdest patterns we see today. Many animals that were never crabs have slowly changed over millions of years. They've become creatures that look just like crabs. Look at this. This is not a crab, and neither is this. In fact, none of these animals started as crabs. They each evolved on their own, over and over, toward the same crab-like shape. Scientists see this happen so often they gave it a name: carcinization. The word comes from Latin and means crabization. It's the tendency for some living things to evolve into crabs. It sounds silly, and to be honest, it kind of is. But when you look at nature, the evidence is everywhere. Some groups turned into crabs millions of years apart. Others did it in completely different oceans. Some weren't even related at all. So why does the crab shape keep showing up? What makes it such a great design? Does this mean all evolution leads to crab? This crab-making idea has inspired a lot of internet jokes. People tease that the crab is life's final, perfect form. Oddly enough, from a science view, there's a bit of truth there. The crab's body plan seems to be a very good, efficient shape. But how can we be sure? The best answer comes from a concept named convergent evolution. This is when different species, facing the same kind of problems, independently develop almost the same features. Think about giant squid. Two separate types evolved to be huge because being big was helpful. So both became giants. But why crabs? And why does it keep happening? To understand that, we need to define what crab-like really means. Because not every creature that looks like a crab is a true crab. Actually, many so-called crabs are just evolutionary copycats. They come from totally different family lines, but ended up looking the part. A crab-like body is usually wide and flat, with a low center of gravity for better balance. That flat shape lets it slide under rocks, hide in small spaces, and avoid being flipped over by water or predators you really don't want to get stuck on your back. Crab-like animals also have a hard shell, but it's for more than just armor. It turns their whole body into a small, shielded unit. When your whole body is a shield, you can survive dangers that longer, open animals like lobsters or shrimp cannot. Crabs also have short, strong legs that give them amazing control over how they move. They're actually better at moving sideways. This helps them escape danger while still keeping an eye on the threat. But this leads to another interesting question. If the crab form is so good, why didn't everything evolve into lobsters? Lobsters have strong armor, they're powerful, and they're clearly successful. They've survived for ages. Why isn't there a big trend of lobsterization? The lobster body plan is actually much more stiff and hard to change. Lobsters have long, segmented bodies with big, muscular tails. That design is very limiting. You can't just flatten a lobster without ruining its basic body structure. Trying to tuck that long tail under the body like crabs do would break its whole form and way of moving. Crabs, on the other hand, start with a tight, flexible body plan. Their body can get wider, shorter, have more armor added, or change position without breaking the design. Once an animal group becomes crab-like, it usually stays that way. Species almost never go back. To re-evolve a lobster shape would mean re-lengthening the belly, rebuilding muscles, reshaping tail fins. It's mechanically very hard. Turning into a crab is simple. Turning into a lobster is complicated. So, what was the first crab? True crabs, a group called brachiosaurs, appeared over 200 million years ago, before dinosaurs walked the earth. But here's the cool part. Around that same time, other crustaceans not in the crab family also started evolving into crab-like forms. We call brachiosaurs true crabs not because they are more real or better, but mostly because they were the first ones found and named. Back when scientists first started sorting life, they didn't have genetics. They only had looks to go on. So flat, wide animals that walked sideways became the standard for a real crab. In a way, they were just the first recorded cases of carcinization. Even the original crabs themselves had evolved into crabs, what are some other famous fakes? King crabs are a perfect example. By their genes, they are actually giant hermit crabs. Their ancestors used old snail shells for homes, but over millions of years, they grew their own hard shells, flattened out, got wider, and slowly shifted into a crab shape because it worked better. Even though king crabs look more like true crabs than like little hermit crabs, they come from a totally different branch of the crustacean family tree. Then think about porcelain crabs. Wait, is every non-crab that looks like a crab just called a crab? Pretty much. Yes. Early scientists called anything with a crab-like look a crab, and the name stuck. We now know their real family ties. Porcelain crabs are actually closer cousins to squat lobsters. They are fragile, their shells break easily, like porcelain, and they don't fight like crabs. But if you saw one walking by, you'd probably call it a crab too. And amazingly, carcinization was happening even before true crabs existed. Fossils like Eocarcinus and Eoprosopon show that crab-like bodies wide, flat, with bellies folded under, evolved again and again. It's as if evolution is pulled toward this shape. But if being a crab is the best form, where are all those old crab-like animals now? Most are extinct. They weren't fully good at being crabs yet. Some didn't have hard enough shells. Others didn't develop the right leg setup for steady, sideways walking. And some lived in worlds that were destroyed in mass die-offs, like the asteroid that killed the dinosaurs. Yet, even when those early forms died out, evolution made the crab design over and over. It seems the rules of physics and the environment keep pushing certain crustaceans toward this same efficient shape. The crabs alive today are just the most successful versions so far. So, what else could become a crab? In theory, any living thing in the right situation could, but in practice, this mostly happens to crustaceans. We've even seen some types of shrimp start to flatten and curl their bellies. They're taking the first small steps on the very long road to crabbiness. But don't worry, you won't see lions or people turning into crabs anytime soon. Our body plans are built for completely different worlds. Still, it's fascinating to see similar shapes pop up elsewhere for the same reasons, even outside of crustaceans. Think about stingrays. They're not crabs, not even close, but they evolved a wide, flat body perfect for lying stable on the seafloor. Just like crabs flatten to stay low and handle currents, stingrays flatten to glide through water with little drag. They aren't becoming crabs, but they found a similar answer. Being flat works. We see this kind of partial matching all over life. Dolphins and sharks, one is a mammal, the other a fish, both ended up with very similar sleek bodies because that shape is best for fast swimming. Birds, bats, and bugs all grew wings because the rules of flying only allow for a few good designs. In the end, it's not that everything is becoming a crab. It's that certain ways of life favor specific shapes. For animals living on the ocean floor, a wide, flat, armored body that scuttles sideways is extremely useful. Crustaceans happen to have a starting body plan that can be easily tweaked into that form, so evolution keeps pushing them that way. Carcinization isn't a guaranteed destiny. It's just nature's way of reusing a winning design when it works incredibly well. And for now, at least, you're safe, as long as you don't start feeling a strange, sudden urge to scuttle sideways.